Here we describe the component of classify and correct analog to digital conversion method. We have n comparator for 4-bit analog to digital converter. We have 4 comparators. We have digital to analog converter like successive approximation technique. We have analog summer subtractor, analog summer here. We have sign detector, detecting sign for decide to perform add or subtract operation. We have a simple A register and T register, A register here and T register here. We have binary adder subtractor. Here is a binary adder subtractor feeding with signal, add or subtract signal coming from sign detector. Now we want to trace the conversion process. We need to trace each component, so we write here analog input, analog summer, sign detector, complementary switch, weighted comparator, state, A register, binary adder subtractor, add subtractor, T register, and DEC. Consider we want to convert 2 volts at input. Analog summer takes input from analog input and DEC. DEC take input from a register. A register initialize at 40 for 4-bit converter. So DEC output is 0. But DEC output is inverted. So we have a negative sign at output. So actually analog summer subtract DEC from analog input. So we have analog input, which is 2, minus the output of DEC, which is 0. So sign detector detects the output of analog summer, and the analog summer output is also inverted. So the output of the analog summer is minus 2. Sign detector detects the sign is negative. So it invokes a complementary switch to take the inversion of the output of the analog summer to return it back to positive value. This because all the output of the complementary switch is feeding to the weighted comparator, and all voltage reference of the weighted comparator is positive voltage, which is putted at this weight. For the first comparator, we have a voltage reference set at 1, 2 to the power 0, which is 1. And for the second comparator, voltage reference set to 2 to the power 1, which is 2. For the third one, set to 4, which for the fourth one set to 8. So we need a positive voltage forever from the output of the analog summer. So we need the absolute value of the analog summer output. And this what happened exactly by sign detector and complementary switch. He takes, in the case of output voltage from analog summer is positive, he takes the output from the analog summer. In case of the output of analog summer is negative, he takes the inversion of the output, so invert it to positive. In our case, we have a negative sign, so complementary switch takes the input from analog inverter, and the output from the complementary switch become positive. So the output of the complementary switch become positive. The weighted comparator finds that input is 2. So the first comparator is switch on, second comparator is switch on because the input is bigger than or equal the reference voltage, and the third one is switch off, and fourth one is switch off. So the first suggestion from the weighted comparator is for the analog input is 0011, which is close to 2, but it's not 2. This feed to binary adder subtractor, and binary adder subtractor perform add or subtract this value to a register. The add or subtract is determined by the sign detector. In case we find it, sign detector find negative value, we perform an addition, so negative equivalent to add process. So we add a register which contained is 40 to the suggestion coming from the weighted comparator. So a register contain 40, and binary adder subtractor output after addition is 000 plus 0011 from weighted comparator, and put these two into T register. So T register content is 0011, and T register in the next cycle put back this value to A register, and A register in the second cycle becomes 0011. After that, we find that DAC converts this back to analog, so this equivalent to 3, but DAC output is inverted, so this equivalent to -3. What happened here? This input feed to analog summer, and analog summer add this to the input plus -3 and give an inversion to the output, so this is -1 is equal 1, so output is the analog summer is 1. Sign detects that the output is positive, so the operation is subtract. The next operation is subtract. Comparator switch takes the output directly from the analog summer, we don't need to invert it. So, and this feed to weighted comparator. Weighted comparator give expectation. The first comparator is on, the second comparator is off, and the third is off, and the fourth is off. After that, this is feeding to binary adder subtractor, and register contained is 0011. The operation is subtract. So subtract the content of a register, which is 0011, from 0001, value suggested from weighted comparators, and this gives 0010, and put this to T register. So T register content is 0010, and this put back to A register in the next cycle. This value put back in the next cycle to A register. So A register now content is 0010, and the DAC connected to A register converts this back to analog. So DAC content, and because the output of the DAC is inverted, so the output become -2, and -2 and -2 feed from digital to analog converter to analog summer. So -2, so analog summer takes input, which is 2 plus -2 equal 0, which initialize end of conversion. So the output in T register is the output of the converter, which is correspond to 2 voltage, 0010. Here we want to calculate the number of clock cycle required for this conversion. Number of clock cycle required for edge trigger design, which is using both falling and raising edge of clock cycle to activate set and reset of register, to put the output of the addition or subtraction process and binary other subtractor to T register, we consume half clock cycle. To put back this value to A register, we consume another half clock cycle. So we count the number of clock cycle from this conversion. We put the output of the binary other subtractor to T register here. So we consume half clock cycle, plus we put back from T register to A register, we consume another half clock cycle. Here we put the value of A register plus the value coming from weighted comparator, and put this value plus or minus, here minus the value from the weighted comparator, so in the T register, so we consume half clock cycle. We put back this value to A register, we consume another half clock cycle, so we consume total 2 clock cycle.